Hello viewers, welcome back. In this part of our tutorial series, application of step 7, we'll be adding overload and mode selection to our conveyor system. Let's get started. So the first item that we'll be adding will be an overload unit. On the screen now we have our overload system. It's having a power section of it, and then we have the control side, which is 95, 96 normally close, and then 97, 98 normally open button. We will be using this system to monitor overload. So what's the purpose of an overload system? Overload, basically it's used to monitor running over current, which implies that whenever the motor is running and it detects any overload on it, it's supposed to detect this fault current and then trip to prevent the motor from burning. And to do this, you need one of this thing, which is the overload unit. And then the overload unit is having two parts. One part is the power section, which opens whenever it detects overload current, and then we have the auxiliary side of it, which is used to monitor and know the state of the overload relay. Okay, so to wire the control section to the PLC, you need 24 volt supply to the 95 terminal points of the auxiliary contacts, and then from the 96 section you will get a 24 volts. Because this section is normally closed when the overload is in normal state, you will always get 24 volts going out, which will be connected to the PLC, and then the PLC will monitor this 24 volts to know whether the relay is in good conditions or not. So now that we have a clear understanding on how to wire the overload to our PLC and also the functionality of the overload relay, we'll go ahead and then implement this overload in our step 7 program. Okay, so we have our step 7 program right here, and then we have our application of step 7, and then in it we have the FC1. So I'll double click on the FC1 to open it. Okay, so we have our logic right here. In the previous video, we were able to add other stuffs to our PLC program. Today we'll be implementing our overload logic right here. Okay, so our first logic is our conveyor 3 logic, and then looking at the program right before us now, we'll be able to introduce the input unit that is going to monitor our overload. So I insert a new contact. So this is the overload for our third conveyor, which is BC03. But we first have to have a look at the input that we've not made use of. To do this, you can go to options, you come to reference data, and you go to display. Okay, so this will open the reference data point for you. You click OK, and then you can see all our timers, and then also the inputs and the memories map right here. You can start with I1.0. Okay, so I1.0 is going to be the input that is going to receive our overload signal. So I'll rename it. Which is going to be our BC03 underscore OL overload. So I can call here overload. Okay, so we've inserted the BC03 overload signal. So whenever we lose this particular signal, the conveyor is going to stop, which will also in turn stop the other conveyor. So we'll move to conveyor 2, which is BC02, and also introduce this overload into it. So this is the logic that is controlling the BC02. So I go to the input section of our timer and then insert a new contact, and this is going to be the overload for our BC02. So pi 1, and then I can also give it a symbolic name, BC02 underscore OL overload. This is going to be my overload. Okay, so I have the overload of BC02 also inserted. I'll move to BC01 and then insert another overload right there. Okay, so this is going to be my I1.2, which is also available. Okay, then I'll rename PC01 underscore overload. Okay, so we have 3 overload applied to all our units. And basically, this is how you introduce the overload into your logic. Okay, so we can save and then we can start our simulator and then check. So I'll move to the step 7 interface. I'll go into the simulator. Okay, so because I just started, I will download the entire program. So download. Okay, so I have the program downloaded, and then I'll add a new input because now I've moved to byte 1. So I'll insert new input, insert input variable, and this is going to be my byte 1. Okay, I can then put the PLC into run mode. Okay, it's in run mode now. I can then open my program. Okay, so I can go online and then I can bring my simulator. Okay, so currently the conveyor system is down, and then now my stop is normally closed, so I have to take it closed. Remember, we've now added the overload. The overload is also normally closed, so I have to close them. So 0.1.0 for conveyor 3, it's ready. 1.1 for conveyor 2, it's also ready, and then 1.2 for conveyor 3, also ready. So with all the overload okay, I can start the system. If I start 0.1, the conveyor should start. I have the emergencies also off, so the emergency 0.2 must also be ready, and then also the pull rope pull cord must also be ready. So immediately they are ready. Okay, conveyor 2 is on now. We look at conveyor 3, also on. Okay, so now let's test our overload. Conveyor 1 is on. So when I drop, let's say for instance conveyor 1 experience some restriction in the belt which caused the motor to trip, so we lose the overload signal, which is 1.0. Conveyor 1 goes down, and let's check. We can see that the other conveyors will also go down as well because they are all running in sequence. Okay, so I'll bring conveyor 1 up again, and then because the start is already ticked, so the other conveyors also will start. Okay, started. So let's say whilst running, conveyor 2 also experience an overload, and then we drop, which is 1.1. I'll take, and immediately conveyor 2 goes down, conveyor 1 also goes down as well. Okay, so basically this is how you implement an overload in the conveyor system. Our next stage is to implement a mode selection. So mode selection, this is basically to help us so that we can select between auto mode and then manual mode. Sorry, in local mode. In auto mode, which means the system will be starting sequentially, but in local mode, we should be able to start the sequence in the system individually, so that if a technician or a maintenance personnel wants to work on the belt, he can either start belt 1, belt 2, or belt 3 independently without running the whole system in auto. Okay, so to do this, we need a selector switch. So we have a selector switch right here, and then we need to wire the selector switch. So we have 24 volts also connected to one end of the selector switch, and we can see the switch layout right here. So if one of the switch normally open switch, one end receives the 24 volts, the other end would then send this 24 volts back to the PLC to tell the PLC that indeed we are at closed position or open position, or whether we are in manual position or auto. position. Okay, so this is the concept, and you can see our faceplate right here, auto and then manual. So if you need auto position, we can then start this system sequentially using the auto mode. And when we are in manual, or what we term as the local position, we should be able to start the conveyors individually. Now let's see how we implement this in step 7. Okay, so we will need a start push button for local start, or what we term as the local start push button. So we need to introduce it into this particular logic, which is BC03 logic. So looking at the logical arrangement, we have our stop push button here. This start push button is basically for our auto start. So we can rename this one. Then this, give it a comment. So this is going to be our auto start button. So we introduce and this is going to be the button that we'll use for the local starting. And if we look at the inputs, we've made use of up to 1.2. So 1.3 will be available. So I1.3. Okay, so I1.3. And then we need another condition, the condition that we are in auto mode before we can run. So we bring that condition right here, and then we can close this particular point. So this is our, so give it a symbolic name. This is going to be our local start. BC03 underscore local start. And then our selector switch. Our selector switch, when it's in the close position, which means we've selected to move in the local or to be in manual mode. So here, when this side is open, which means we are in auto mode, then we should not be able to start locally. So this our input is going to be I1.4, and this is going to be mode selection. So mode cell. Okay, so this is our mode selection input signal. So that when we are in the local mode, here will be closed, and then when we press the start button, we can then start the system. Okay, so basically we are done for the BC03. We can analyze the circuit. So we have our stop push button here. We have our auto start. We have our hold on conditions here, which is the output command, and then the feedback also from the contactor that we implemented in the last video. And then we have our local start, and then we have our mode that is going to prevent it from starting in local mode whenever we have not selected local. Okay, so we need our mode also here to prevent us from starting in auto mode when we are not in the mode in the auto selection point. So at this point is going to be a normally closed contact, because when we've not selected, it should be in auto. When we select, then we move to local mode. So it's going to be the same input, which is our mode selection input, which is I1.4. Okay. Alright, so we then move on to our next conveyor, that is our BC2 conveyor. So here we can also implement it here. This timer is basically for auto mode, and now we are going to implement a local mode selection logic. So to do this, we can do this in two ways. First, we can create a new network, and in this new network we can then introduce our logic. But basically we will be energizing the same output, so the output can no longer be on only the timer. So I need to move this output from here and connect it on this particular network. And then what is the condition to bring this thing on? We need a stop push button, but remember we'll be using the same stop push button. So I can copy this particular logic and then paste it right here. And then we will need a start command. So our last start that we used was 1.4. So I can make R1.5. And this is going to be BC02 local start. So BC02 underscore local start. Okay. By local mode, we need to hold it on. So I need another connection here. And this is going to be the address of the output. That's the BC02 output. So it's Q4.1. So we are done with our simple logic. Okay. So now in manual mode, when we press the local start push button, we should be able to start and hold ourselves on. But then we should not be able to start until we have selected that we are in manual or local mode. So to do this, we need to introduce the local signal here, just as we did at the top section. This is our local signal. So I introduce this. That is going to be our mode select. Okay, so whenever we select, the mode is selected, then we can start in local mode. But if the mode is not selected, then we are in auto mode and we should be able to start in auto. So to do the auto starting, I need to energize this save output relay. I need to add the condition right here. Okay, so the auto condition will be this timer coming on. So I need to put a new contact, and that is going to be the command from the timer. But then immediately the timer comes on, I need to also be in auto mode. So which means I need a normally close here. That is going to be my mode signal. Normally close point of my mode signal, and then I can now move. Okay, so let's analyze this. So basically our stop push button is the same stop for all. Our start when I press the local start, and the conveyor can start. So first I'm selecting I'm in local mode, and then the output will energize. When the output energizes here, will close, and then we will get feedback through this side to hold itself on, even when I release the start push button. Okay. When I'm not in local and I'm in auto, then this section of the code will still hold. Whenever this timer becomes okay, then you can close this section, and then the contactor output can come on. Okay, so this is done. This is the logic for our conveyor 2. We will do same for conveyor 1. Okay, so I'll insert a new network. In conveyor 1, I would like us to use a different approach. So this time we will introduce a memory, or what we term as the internal relay. So I'll bring my stop, my start, and then my local condition. So stop, I can still copy the same stop here, and then the start, I need a new start command for it. I1.6 available. BC01 underscore local start. Okay, and then my mode condition, the same mode condition here, and then my start command. I need to move it from here, which is, and then and I need to hold on. Okay, so this one is done. This is going to be my local mode, and then not using this approach, but using a different approach, then which means I need to add a new network again, and then instead of this being here, I'll copy and paste here. which implies that I need to write this instruction into a memory location, and I can then fetch information from the memory location to control the output on this particular network. So which means I have to give here a memory address, and 0.0 is not in use. Okay, 0.0 is not in use. So which implies that immediately I start in local mode, I will get a signal at this memory point, and then that signal can turn this output on. Okay, or I have another command, which is the command from the timer, also coming right here. Now we'll also be able to start the conveyor. But the timer should be able to start it only when I'm in auto mode. So I'll need the next condition here. So it's supposed to be normally close. Only when I'm in auto mode. Okay. I'll call this one R1, which is first relay. So this approach for BC02, and we use the next approach for BC01. Okay, so basically we are done with this. We will save, and then we can simulate to see whether our code is working correctly. Okay, so I have the simulator open now. Okay, so we can see in auto mode we've already tested. We want to test in manual mode. Overload is okay. Emergency pull rope, everything is okay. Now we are in auto mode already. So if we click on the local start, which is, let's see whether we can run local start, which is 1.3, and we can see that we cannot start because we've not selected that we are in local mode. So now I have to select local mode, which is 1.4. So far as the local is selected, let's try and see whether we can start in auto mode, that is 0.0. You can see that in auto mode we can also not start BC3 because we've selected that we are in local mode. So now I'll do local start. Yes. Okay, so local start went through all right, but our overload is off, so we need to turn our overload on, which is 1.0, and I can start the local start again. And indeed we can see that the started, but then we did not receive the feedback, so we went off again. Okay, so now I start again. Now I put on the feedback time, which is 0.4, and now when I go off, we can see that we are hold on in local mode. So I can do the local stop, which is 0.1, and indeed it stopped. So our local mode selection and then local stop working. Let's move and try that of conveyor 2. Okay, in conveyor 2 we have our logic, and we can see that our local is already selected. So let's start in local mode and see whether we can start. So our local start is 1.5. So I go to start, and then we can see that we've started in local mode, and then when we want to stop, which is 0.1, we can stop. Perfect, working perfectly. Now we move on to conveyor, our last conveyor, which is conveyor 1. The local selection is already on, and then let's see whether we can do a local start. 1.6. You can see that it started, and immediately we start, we can see that it started, and this section also started, and then when we want to stop, also stop perfectly. Okay, so basically we've been able to implement adding an overload protection and also mode selection to our conveyor system. Thank you for watching. See you in the next video. Bye bye.